Hello students. So I'm sure that some of you guys have already completed 3.1, the home automation sensor. Only if you complete 3.1, please go ahead and start your next Tinkercad and next circuit. In the next circuit, we are going to use a gas sensor, and this is applicable and this is already there in most of our homes. Like for example, if there is any fire or any kind of smoke, there is a sensor which detects, and what happens? It creates a sound, right? So here we are not only creating a sound, but we are also creating a small light just for a notification. Because let's say somebody could not hear the sound, but they could actually see the light, right? For that, we are going to create a circuit which looks something like this. Here we are using a buzzer, we are using a gas sensor, we are using bunch of LEDs. So except this gas sensor, you have learned and you have used every single thing so far, right? So this is a quite interesting and very easy circuit if you follow the steps what I'm gonna do. Okay, so by the end of this class you should be able to make this circuit, and you see this how it works. When I start the simulation, and if the smoke is away and if the smoke is way far from the sensor, nothing happens. But when the smoke comes closer to the sensor, you will start hearing the noise, you will start hearing the buzzing sound. So for example, let me remove so that is the idea of this project. Okay, I'm gonna stop the simulation. I'm gonna go to our designs and create a new circuit and name it as 3.2. Just give me 1 second, guys. 3.2 gas sensor. Okay, in this gas sensor, the first thing that you would need is obviously an Arduino kit or an Arduino board, and then you would need a breadboard. A small breadboard would do for this, so I'm going to keep it and reduce the size a little bit. And then move it somewhere over here. Okay, so the two major components of this are gas sensor. You see, this gas sensor has not 3 but 6 pins. So you connect the 6 pins over here, and also the buzzer connected somewhere over here. Okay, now you take the 5 volts from here and connect it to the and you take ground and connect it to the negative. So ground, I want to change this to black. This one I want to change it to red. Okay, and then we're going to use two LEDs. One is going to be red, one is going to be green. Green is one is going to be red and the other one is going to be green. Okay, so green is a safe color and red is something that is alarming. Okay, so red and green. So red is going to be connected to pin number 12 because it is digital pin. I'm going to use pin 12 and connect it to the anode of the LED. Same thing I'm going to do with pin number 11 and connect it to the anode of the green LED. Alright, Now I'll take pin number 10 and connect it to the gas sensor, to the buzzer, because buzzer must act according to the, if there is a gas, in the presence of gas, the buzzer is going to make some noise. And then this one, H2, must be grounded, so any ground cable is always going to be black color. Okay, once this is done, let's say this is my analog pin, right? So I'm going to connect this to my analog 5. Any analog color is going to be always blue. I'm just trying to organize my cables so they don't look cluttered. And your circuit looks neat. Now all I have to do is connect the resistors. Okay, before I connecting the resistors, so all of these 3 pins, they need 5 volts. So either you can connect all of these 3 pins like this, or individually you can connect each pin, then hold on. So now every pin has 5 volts to it. So you need 5 volts for pin 1, A1, H1 and A2. All of these 3 pins need 5 pins. I just connected these 3 and I'm giving them a 5 volts. Once you're done with that, the only thing that is missing is keeping the resistors. So let me see the resistors value that I've used in the previous project. This is 10 kilo ohms, 200 ohms and 500 ohms. So you can just skip. So this is going to be 10 kilo ohms. The first one that you're going to use 10 kilo ohms. This must be connected to the ground. Next one is 500 ohms. Another one is 500 ohms. And then another one is 200 or 220, whatever. So let us take 200 ohms and then connect it over here, and this 200 ohms must be grounded. So I'm going to take a black cable and connect it to the ground. Okay, so with this your circuit is done. So make sure that you're doing it right. Now go to the code part, select the text. We're going to delete everything, and then let me make this a little bigger and increase the size so you'll be able to clearly see it. And then you're going to write the following. So I'm sure that you guys have completed this code circuit, and you need to follow the exact same steps like I do for writing the code. So I'm gonna write int LED1, which is connected to pin number 12, right? Yeah, 12. Create a space. Int LED2 is connected to pin number 11. Int buzzer is your speaker is connected to pin number 10. These are all digital pin. Int the smoke sensor or the gas sensor is connected to A5. I'm going to create a new variable. I'm going to name it as sensor threshold is equal to, let's say, give it a value of 500. Void setup. Void setup is always followed with a parentheses and open parentheses because it's a function. And then write pin mode LED1 is output. Even if you forget this one, your code is going to be wrong. So please be very careful. And the next line of code is going to be the exact same thing. So then I'm copying and pasting. Instead of 1, I'm going to write LED2. Okay, and then the next one is going to be buzzer. You're just setting up the modes. Buzzer is also an output. Okay, and then the smoke sensor is an input. So the next one is going to be smoke, or the smoke sensor is an analog input. So you just write input. Then serial dot begin 9600, and then close the parentheses. So your initial function is over. Now you're going to write the logic. So void loop, because it's always going to work, you're going to create a forever loop with void loop int analog sensor is equal to analog read. What are we going to read? We're going to read A5, and A5 is a pin, analog pin, that is connected to the smoke sensor. So you're going to read smoke. Here is a mistake. I need to open the parentheses. After I read the sensor, then serial dot print sensor value. You're just printing the sensor value. Close the, that is called a termination sign. So you're terminating this sentence. In Python you don't have to write the terminations, but in C programming or C++ you need to write the termination. Then serial dot println analog sensor. Make sure that your S is capital. Okay, then click enter. Now you're going to write the actual logic. So the logic is, if analog sensor is greater than sensor threshold, I'm going to copy the same variable Command C and Command V. If analog print is greater than sensor threshold, these are the certain steps that I'm going to do. Digital write LED1 or LED pin 1, which is connected to pin number 12, is going to be high. If LED1, which is red, is on, I want the green to be off, right? So LED2 is going to be low. Okay, and then we are going to create a buzzer value also. So that means if LED1 is on, that means there is some kind of smoke, right? So for that, you're going to write tone of the buzzer. You have already done this when you're creating the piano. Tone of the buzzer is going to be let's say 1000, 350. When it is high, it is going to be 1000. When it is low, it's not going to make any noise. Now close the parentheses. Your first logic is over. What if there is no smoke? Else, you're going to open the parentheses and then write. So you can keep the parentheses down if you want, like this, and then write. Copy the same thing, so you're going to make your code simple, and then write, paste it over here, and digital write LED1 is low. So if there is no smoke, there's no point of turning on the LED red LED. Instead, we are going to turn on the green LED, and then tone, there's going to be no tone. So I'm going to write no tone, but T should be capital here. No tone buzzer. And if there is no tone to the buzzer, you don't have to give any values. So you can remove all the values. And then close the parentheses. After that, just create a delay of maybe 1 millisecond or 0.1 second, or that is delay 100, and then close it. With this, you complete your code. If everything is right, when you start the simulation, it should work. So there is smoke here. When there is smoke, it makes noise. But when the smoke is more than 5 centimeters away from the sensor, it does not make any noise. But when the smoke is coming closer, it makes noise. With this, we complete our second topic. So this sensor or this code is there in everybody's, almost everyone's home, right? If you have a gas sensor on top of the living room or in kitchen, most likely they are using the same circuit, but they might not be using Arduino, they might be using some other microcontroller, but the logic behind this is exactly the same. So I hope everybody will be able to complete this. So you can take a day or two as your time to complete this project, because I know this is not going to be easy. You're going to run into a lot of errors, and there is one more thing that I want you guys to notice. But if you get into errors, I don't want you guys to give up. I want you guys to still try this out to get the results. I'll start the simulation. The smoke is quite far. Okay, hold on. So click on serial monitor. So you will be able to see that what is the sensor value over here. Sensor value is 487. It keeps coming. But now go to the bottom. Then Whenever it is more than 500, it makes noise. Whenever it is less than 500, it does not make noise. And notice the LED light. Alright, with this we complete our second topic in chapter 3. Good job guys. Thank you. I'll see you again in our next video.